So I welcome you all in this course, Introduction to Heat Transfer, a practical oriented approach. Today is a lecture number 8, Natural and Forced Convection. So in this lecture, we are going to see the difference between natural and forced convection. These are the modes of the heat transfer. That means in general, the modes of the heat transfer are three: conduction, convection and radiation. But in convection there are again two modes, so that are natural and forced. So we are going to distinguish how these modes of heat transfer are differ from each other. So let's start today's lecture. I am Amraraj Sawant, Assistant Professor, Department of Mechanical Engineering. So briefly just recall these, that what is convection. So convection is a transfer of heat between solid surface and the fluid, that means gases or liquid that are in motion, and it happens due to conduction within the boundary layer. That means the heat passes from solid to fluid molecules near the surface. So let's consider this as a metal block, okay, and let's say this metal block, if this metal block is heated, okay, and the surrounding of this metal block is air, okay. So first of all, the layer near to this heated surface will transfer the heat by the mode of conduction to solid, this solid to the nearby fluid molecules, and that nearby fluid molecules to nearby fluid molecule layer, the process of heat transfer will take place by the conduction. So one type of process is formed in the convection like this, and another is advection, which is a bulk motion of the fluid. The bulk motion of the fluid or advection, what is mean by that? That means in this heated plate, let's say the first layer of fluid is get heated, and the second layer it will also get heated by the conduction from first layer to second layer, okay. But when these fluids, that means the air is in a motion over this hot plate, then we can observe the advection phenomena or the heat transfer due to this motion of the fluid, which is, let's say, for an example, you can take an example of air. So if this hot plate and above which the air is, if we blow air, okay, which is having lower temperature than this hot plate, then the heat transfer will take place first by conduction of first layer and second layer of air due to conduction, and second type is advection due to the motion of this air. So in total this means the convection heat transfer. So depending upon how the fluid motion is generated, the convection again categorized as a natural, that is free convection, or a forced convection. So we are going to see in this lecture what is a natural or free convection and forced convection. First of all, natural or free convection. So natural convection occurs when the fluid motion is caused by density difference. This is the main keyword in this natural convection, okay. So natural convection occurs when the fluid motion is caused by density differences resulting from the temperature variation in the fluid, and there is no external device like a pump or fan to flow or to blow the air or to flow of fluid over the heated plate. So what is mean by the density differences and how it is created? Let's take again this example of this metal plate, okay. If this metal plate is at a temperature higher than the surrounding temperature, okay, the surrounding for this metal plate is air, and this metal plate is at a higher temperature, let's say 70 degrees Celsius, and the surrounding air is having a 30 degrees Celsius temperature, then the first layer of air which is going to be at a contact with this hot plate, okay, and the second layer, okay. So we are going to see this density difference in layer phenomena, okay, or in layer wise. So first when the first layer of air will get heat, okay, will get in a contact with this heated plate, then due to heat they will lose the water vapors, okay, the air will lose the water vapor, and due to heating the density will decreases, okay. And as we know the simple physics, when the density will decrease of any fluid, then the fluid will float or the fluid will rise up, okay. So when the first layer of air, when it is getting contact with this hot plate, then due to the heat transfer to that first layer of air, the density of that first layer will decrease and that first layer will rise up, okay. So while rising up, the again the next layer which is going to be in a contact with this hot plate will be the layer which is having low temperature, okay, because the low temperature layer will have higher density and higher density particle will sum up at the end, okay. So this cycle will continues, and by this virtue of this density differences, the natural convection phenomena occurs. Figure illustrated here, the burner, okay, keeps heating this vessel or a cooking vessel. So by these you can see these arrows, and these arrows, so the first layer of fluid or liquid here in vessel will get heated, and due to which the density will become lesser, and due to density will become lesser, this fluid layer will rise up, okay. And whatever the fluid layer is above, where the fluid is having lower temperature than this than this layer, so that fluid will be get deposited at the this end, and once again this cycle will takes place, and due to this cycle the natural convection phenomena occurs. So we can we will see here the simple difference between the natural convection and forced convection. For forced convection, there must be some external device like a pump or a fan to be needed to flow this fluid layer over the hot plate, okay. So what is the physical explanation of natural convection? As I have explained just before, same the heated plate, and whatever the density difference is causes due to the fluid particles going to be in a contact with this hot plate, and again they due to they are in a contact, so they will have they will gain some heat, and due to which their density will decrease and they will rise up, and whatever the other particles are there which is having higher density, they will again getting into the contact with hot plate, again they are getting some heat, and again they are losing their density, and again they are rise up. So this cyclic process goes on, and which is called as a natural convection, and whatever I explained here just written, okay. So physical explanation of natural convection: a solid surface like a metal or a pipe is hotter than the surrounding fluid, okay. The fluid near the surface get heated by the conduction. Likewise I said, in a layer, the first layer and second layer, if the fluid is getting in a contact with a hot plate, let's say this is a hot plate and this is the first layer and this is the second layer, so in first layer and second layer the heat transfer will takes place by the conduction phenomena, okay. So as the fluid heats up, it expands and becomes less denser, and because of the difference in a density, the warmer fluid rises and the cooler fluid from above sinks to its place, okay. And this will create a natural flow or a current transferring the heat without any mechanical force. This is called as a convection current. All these phenomena of density difference and moving in a cycle is called as a convection current, and it is entirely driven by the buoyancy due to the thermal expansion of molecules, and overall this is called as a natural convection heat transfer. So natural convection, whatever I just explained here, you can see this in a figure. So natural convection mechanism, likewise, let's say this fluid molecule, just one second. Okay, let's say this fluid molecule which is having higher in a density. So this higher in density fluid molecule will be sink up to the bottom where the hot cylinder is there. Okay, and while getting in a contact with this hot cylinder, it will loses, okay, or it will gain the heat and loses the density. That's why it will rise up. And again the newer particle which is having a higher density will again sink up to the hot cylinder, okay, or the surface here, and when it will get in a contact with this hot surface, then again it will lose its density, and due to losing their density it will rise up, and this is formed which is called as a convection current. And due to this all mechanism, which is a natural mechanism without any mechanical thing, so this natural mechanism is altogether called as a natural convection heat transfer phenomena. Okay, so governing equation, as we see in last lecture, the governing equation for convection is by Newton law of cooling, which is Q is equal to HAS. Actually here AS should be denoted. AS means surface area. So Q is equal to HAS into Ts minus T infinity, where Q is heat transfer rate, where H is a convective heat transfer coefficient, where A or AS is a surface area, where Ts is the surface temperature of that object, minus T infinity, where the T infinity is a ambient or a surrounding atmospheric or surrounding ambient temperature. So in convection heat transfer, but in natural convection heat transfer, the H value is smaller. Okay, typically it is from 5 to 25 watt per meter square Kelvin. H means convective heat transfer coefficient value should be lesser. Why? Because in a natural convection heat transfer, the flow of fluid over the hot plate, again consider these, so flow of fluid over the hot plate is governed by naturally due to the density differences, what we call as a convection current. By this is flowing not because of external work. So this is the flow of fluid will always be due to the convection current, and that's why the H, which is convective heat transfer coefficient, which is mainly dependent on the flow properties or the fluid properties. So that's why in natural convection the H value should be smaller than the forced convection. So real life example of natural convections are heated room. So in heated room, the warmer air near the radiator rises. Same phenomena of density differences and convection current is used in heated room in foreign countries like USA and UK. So boiling water, here you can see the boiling water, the hot water at the bottom rises. So this is a everyday life example. You have seen this in your hostel. So if you put electrical heating element in a bucket of water for taking your bath, so after removing your heating element, you can observe that the first, when you put your mug in the bucket of that water, the first mug or first 2-3 mugs which is having that water will be higher, the water will be at higher temperature, and while you use that water, and what is the water left over at the bottom, the temperature of that leftover water is lesser than the starting ones. It is why so, but the main condition is that before doing this, if you don't mix up or don't just stir the water, then this condition you will observe. But just only you put your electrical rod in your water bucket, and if you heated that, and after completion of heating of water, if you just remove the electrical heating rod, then you can observe that the first top layer of your water which is in your bucket, okay, so the first layer will have some higher temperature, and the bottom layer will have lower temperature than the upper layer. You just observe. But the necessity condition is what? Before stirring the water, before just mixing the water, so you can observe that the top layer will have higher temperature. And why it is so? Because of density difference, and this density difference is created due to the convection current. Okay, so cooling of metal rod in air, no fan is involved. If cooling of metal rod is there in air, just still air, no fan is used, then same convection current will occur, and due to which the natural convection heat transfer will occur. So hot engine block exposed to the still air. So here just the real life examples are illustrated, but more together we can say that any heated metal or piece or any object, if we put in a still air, then whatever or however the heat transfer will take place in that still air is must be through the natural convection process. So next is a forced convection. Forced convection, as just before we have seen that the forced convection is purely done by the external force when the pump or fan is to be used to flow of this fluid motion. Okay, so forced convection, in forced convection is a type of heat transfer where the movement of fluid over the surface is caused by external means such as pumps, fans or blowers or wind, anything. Okay, and this movement enhances the heat transfer between the solid surface and the fluid by the mixing of the fluid more efficiently. What is mean to say here? In a natural convection process, we are not having control over the fluid motion, because the fluid motion is takes place due to the density differences what is created due to the temperature or heat going to be transferred from that layer to layer. Okay, so we don't have any control over that flow of fluid, but in forced convection we have control over that fluid motion by supplying the air or by flowing the air through the fan or blower or any external device like pumps. Okay, so that's why while we control the motion of the fluid, then it is enhanced heat transfer or moreover heat transfer we can achieve. Okay, so physical explanation, same what I have just explained here is written in a physical explanation. So a solid surface which is at a different temperature than the surrounding, which is cold or hot. Okay, an external device, pump or fan, is forced the fluid motion to flow over the surface, and this fluid motion movement disturbs the boundary layer and causes the mixing of hot and cold fluid particles. Means whatever the density difference is created or whatever the convection current is created naturally, we are in forced convection, we are doing it by using some external device like pump, fan or blower. Okay, so this fluid motion disturbs the boundary layer and causing the faster mixing of hot and cold fluid particles. So this results in a higher rate of heat transfer compared to the natural convection. Why it is so? Because we are controlling the motion of a fluid. Okay, whatever the air is passing over this hot plate, we are controlling or we are supplying more air with a more velocity, and that's why the heat transfer is enhanced rather than or compared to the natural convection. So mechanism and governing equation, as like I have said, that for convection the governing equation is always be governed by Newton's law of cooling. Where whatever the natural convection is there or forced convection is there, the governing equation should be based on Newton's law of cooling. So the external devices forces the fluid to flow over the surfaces, and this increases the mixing of fluid particles and reduces boundary layer and enhances the heat transfer. So like I have said that it is only or convection heat transfer is governed by Newton's law of cooling. So here H value, H means convective heat transfer coefficient. So here H value is much higher than the natural convection. And why it is so? Because H means convective heat transfer coefficient is purely dependent on the fluid properties and the flow properties, and that flow we are controlling here by some external devices like pump and blower. So that's why here the H value is much higher, and because H value, you can see here, if H value is higher, then heat transfer rate, whatever may be the case, will also be higher because it is directly proportional. So real life example of forced convection heat transfer are CPU fans for cooling in computers. So CPU, you have central processing unit in your computers, maybe a laptop or a PC. You have a fan like a structure. You have seen that the fan like a structure is used because for smaller area you have to extract the heat in more efficient manner. So that's why the fan or the external device is used to control the fluid motion. Okay, so water flowing through the radiator tubes in IC engine or in normal cars, we have seen that the radiators will use some water pumping devices which called water pump. The water pump is used to flow the water more in more velocity, and more mass is transferred. So that's why the more effect of cooling we can get. So in air conditioning system also the pump and blower system is used. Okay, so cooling of a car engine with a coolant, and same the coolant will be provided to engine by using the pump. Okay, so industrial heat exchanger. So these are the some real life example of forced convection heat transfer. So why forced convection heat transfer is preferred in engineering? Why not we preferred natural convection? The basic thing is that we don't have a control of flow of fluid in a natural convection, and in forced convection we have a control over the fluid motion. Okay, so much faster heat transfer than the natural convection, but obviously because we have control of fluid motion in forced convection, that's why the much heat transfer will be observed rather than in natural convection. So moreover controllable, that is flow rate, direction, temperature, that can be regulated by some external devices. Essentially where the high heat loads needs to be removed quickly, that is high performance electronics and engines, like I have said in PC or CPU, you have to quickly absorb or quickly release that heat. That's why the fan or blower arrangement is there in CPU. So enables use of compact design where the small heat exchanger or radiators are used. So in likewise same, you can take an example of your laptop. Right now the liquid cooled technology also used. So that liquid cooled technology also uses some external devices like small fans, okay, or blowers to blow the air with that liquid cooling, so that the heat transfer rate will be more. Comparison table of natural convection and forced convection. Whatever we have discussed earlier, just it is put in table form. So fluid motion source, the fluid motion source in a natural convection is a buoyancy, which is due to the temperature difference or density difference. So in forced convection we have used external devices like fan and pump for fluid motion. So heat transfer coefficient H will be much lower in a natural convection, and whatever the reason we have discussed. Okay, so H will be the lower, which is around 5 to 25 watt per meter square Kelvin, and in forced convection the H, which is heat transfer coefficient, will be higher, so that the higher heat transfer will achieve. So efficiency wise the natural convection is a less effective, and forced convection is a more effective. So flow velocity, where the natural convection flow velocity will be lower because it is completely due to the natural buoyancy force which is created due to the temperature or a density difference. And in forced convection, because we have used the external devices like fans and blower, the flow velocity of fluid particles is higher. So typical applications in natural convection, we can use the natural convection in radiators or room heating. Basically in room heating the natural convection is used. And in forced convection the typical applications are cooler, condenser and fans and blower system used in power plants. So but in forced convection we can vary the flow, or we can control fully the flow by varying the input to these external devices. So summary of this lecture: natural convection is a passive and driven by the temperature, induction and density changes. Okay, and in forced convection it is active and driven by some external devices. So forced convection provides better heat transfer performance. That means we can achieve higher heat transfer rate whenever there is a system where we have to extract the heat very quick in a very quick manner. So there we use a forced convection type. But in natural convection used where simplicity and no power input is preferred. Also natural convection heat transfer also preferred, but where we don't have any input power and where simplicity design is there, then we have used natural convection. So both the types are governed by the same basic convection heat transfer equation governed by Newton's law of cooling, which is equal to Q is equal to H into A Ts minus T infinity. So thank you very much. So we will conclude this lecture, and you will have 20 MCQ assignment over this lecture, and you will have to attempt this assignment online, and the online link is provided in a description box, and you can ask anything about this lecture in discussion forum. So thank you.